In this lesson, we're going to be talking about radian and degree measures of angles. In geometry, you use angles and you talked about their degree measure, whether their degree measure was 30 degrees, 45 degrees, 59 degrees, 90 degrees. But today we're going to be looking at how can we take these degree measures and turn them into what we call radian measures. I'm going to break this lesson up into two parts. So today we're going to be looking at the unit circle and angle measures, converting between degrees and radians, and then commonly encountered angles in our unit circle. So our radian measures, okay, we're going to let this Greek letter theta, okay, we're not going to use letters to represent our unknown angles. We'll use Greek letters now that we're in pre-cal. Theta is going to be an angle at the center of a circle that has a radius of 1. So I'm going to flip on over here to this picture. So I have this angle inside of my circle. I don't know what it is, so we call it theta. This circle has a radius. Remember, a radius goes from the center of the circle to a point on the edge of the circle. Each radii here are 1. Remember, a circle has an infinite amount of radii. But the radian measure is this green part. It is all of this around the edge of my circle. Now, when we talk about radian measures, degrees are just degrees, like 30 degrees, 45 degrees, so forth. Radians are a little different. They are in terms of pi. And the whole reason is around my circle, that's my circumference, and it's 2 pi r. So this little piece here that I'm looking at to turn into a radian is just a proportion of my circumference. So like if it's half, I would divide it by 2. If it's a fourth of the circle, I would divide it by 4. But I will still be left with pi in my answer. So a radian measure is going to have pi in it, and the radian is this part suspended by the 2 radii that go around the edge of my circle. Now to convert these is very easy. There's 2 formulas down here on the bottom. If I know my degrees, so this one I'm going to use if I know my degrees. Okay, if I have some amount of degrees, 30 degrees, 90 degrees, however many, I'm going to take that degree right here, and I'm going to multiply it by pi over 180. And then that's going to change it to radians. Now, vice versa, if I know my radians, I should say known. If I know my radians, I'm going to take that radian measure, and then I'm going to multiply. I'm going to flip that fraction and multiply it by 180 over pi. And the whole reason of that is my radian's going to have a pi value in it, so those pi's are going to cancel each other out. And we're going to look at a few examples today together. Okay, the first one, we're going to convert these, express pi over 3 radians in degrees. So I'm going to take pi over 3. It's a radian. I want to convert it to a degree. So I'm going to multiply it by 180 over pi. That was if I go back over here, if I know my radian, to convert it to a degree, I'm using this one right here, 180 over pi. Now, the whole nice thing about that is my pi's are going to cancel each other out. And I'm going to get 180 over 3, which now just gives me numbers. I am now in degrees. And 3 goes into 180 60 times. So this is 60 degrees. Now, 60 degrees and pi over 3 is a prominent point on your unit circle that we're going to talk about in just a minute. Eventually, you're going to get this unit circle, and you're going to have the whole thing memorized all the way around the circle. Specific points, degrees and radians. Okay, so B wanted us to convert 270 degrees into a radian. So this time I'm going to multiply it by pi over 180. So I get 270 pi divided by 180. And then I'm going to take and I'm going to simplify these. The zeros can go away. 9 will go into both of those. 3 over 2. So I get 3 pi over 2. And again, since it's a radian, it should have pi in it. And that was B. And now C says negative 2 radians. Okay, so I'm going to multiply it. I want to change it to a degree. So I'm going to multiply it by 180 over pi. Now, this negative 2 does not have a pi to cancel out with the pi on bottom, but that's fine. Negative 2 times 180 is negative 360 over pi. And I'm just going to take my calculator and I'm going to divide that. And that gives me somewhere about negative 114.592 degrees. Now, can we necessarily have a negative angle? No, we can't. The negative here, gotta be very careful, tells us our direction around the unit circle. Okay, if it's positive, we are going counterclockwise around the unit circle. If it's negative, we go clockwise around the unit circle. And you're going to see that in just a minute. So, what if I give you a picture? This is what our unit circle looks like. Okay, we start our unit circle at 0. And then if I take and I go halfway around this circle, how many degrees is that? Well, halfway around a circle is 180 degrees. So I'm going to help us kind of fill out this unit circle really quick. Can I turn that into a radian? Because it wants me to determine the radian measures here. I am trying to find this angle that has been formed right here. So if you look, it's 180 degrees plus then just a little bit more past 180 degrees. But really quick, let's take 180 degrees and let's turn it into a radian. So I'm going to multiply it by pi over 180. Well, my 180s are going to cancel, and that leaves me with just pi. So at 180 degrees, my radian is pi. Okay. Now, what if I take and I split this between 0 and pi right down the middle? What do you think my radian at this point up here is going to be? If this is pi halfway around my circle, what's halfway? That would be pi over 2. Now, what if I take and I break this thing down even more here in this first quadrant and I break this part in half? What's halfway between 0 and 1/2? 1/4. So this would be pi over 4. So, with that in mind, how far here in green have I gone around this unit circle? So the angle theta here is in my standard position. Since I'm going counterclockwise, that means my angle is positive. And I just said that we went all the way to pi plus just a bit more. Okay, and so what is that bit more? Okay, well, if we go back and look, this bit more here, right here, is the same as what I did right here. So that means that bit more is pi over 4 radians. Okay, so to find my theta, so to find all the way around here in blue, okay, I've got pi plus this pi over 4 that we just said. Okay, so I'm going to go back. So I'm going to do pi plus pi over 4. Now, in order to add those, I have to have the same denominators. So that's going to give me 4 pi over 4. And I'm going to add them, and I'm going to get 5 pi over 4. Okay. Now, looking at this next one. This time I'm going the opposite way, which means I'm going to have a negative direction. So let's just think, if this was pi, what's all the way around my circle? Another pi, which is 2 pi. So if we look at this thing, I've gone a whole ways around my circle. That's a whole 2 pi. Plus then, I've gone another halfway around my circle. And then I've gone this much. Now that is not pi over 4. This part right here is actually pi over 3. Okay, so to find this one, again, we've gone negative 2 pi, we've gone negative pi, and then we've gone a bit more. Okay, that bit more is negative pi over 3. So I'm going to have negative 2 pi. Then I'm going to have negative pi, and then I'm going to have negative pi over 3. And they're negatives because we're going clockwise around this circle. Now, I need a common denominator of 3 for all of these. That one's going to stay. So that's going to give me negative 6 pi over 3, negative 3 pi over 3. And then if I go through and I add these together, that's going to give me negative 10 pi over 3. And that's my distance around. Now, we're going to work more with this unit circle. That does take a little while to get used to. I'm going to stop right there today with the notes. Tomorrow, we're going to look at arc length, angular speed, and circular area. I do have an assignment for you to do that is on Google Classroom, so you're going to need to go work on it.